Hello, welcome to the EPG Pathshala program in linguistics. I am Pramod Pandey, Center for Linguistics, Jawaharlal Nehru University. Today we will discuss two processes of speech, namely phonation process and the oro-nasal process. Once the airstream process begins to flow from the lungs into the vocal tract, it meets its first obstruction in the larynx. The larynx takes over and produces the various types of speech sounds by modulating the air through it. The larynx is placed in the vocal tract below the pharynx and the velum. Now, evolutionary biologists tell us that in the evolution of human species, from the chimpanzees and the apes, the larynx played a crucial role in development. It was lowered. Whereas in animals, the larynx is high up, giving mainly one dimension of speech. With the lowering of the larynx, the human speech came to have two dimensions, a horizontal dimension and a vertical dimension. Let's take a look at the structure of the larynx in chimpanzees and apes and human beings. The location of the larynx leads to three important functions. One, it controls the breath flow. It protects the windpipe, and it regulates the production of speech sounds. The central organ of the larynx is the vocal folds, which perform all the three functions. So the vocal folds control the breath flow, the vocal folds it is that protect the windpipe, and the vocal folds it is that regulate the production of speech sound. Let us take a look at the two extreme positions of the vocal folds given in the diagram here. What you find is that the vocal folds are closed in the upper figure and open in the lower figure. We can have a look at the various positions that the vocal folds take by looking at the following video. So you have looked at the various shapes of the glottis in the video. Some of the shapes are shown in a static form in the figure 5.5. As you will see there, from very wide opening to very slight opening, and then in between there are two medial states of the glottis with regard to the opening. Now, this whole thing is manipulated with muscles of which the vocal folds are made and which surround the vocal folds. There are two types of muscles and cartilages that control the movement of the vocal folds and the larynx. One type is the one which is responsible for the vertical movement of the vocal folds. The vertical movement of the vocal folds is important in the production of various types of sounds, such as different qualities of voice. Especially, you will have noticed that ventriloquists are very good at manipulating the larynx in order to produce different types of voice. Also, it is the movement of the larynx that is responsible for the production of at least two different types of sounds we saw in the last module, namely implosives and ejectives, which are produced by the lowering of the larynx and the raising of the larynx respectively. The horizontal movement of the vocal folds are responsible for the various states of the glottis that you saw. Thus, we have sounds which are voiced, sounds which are voiceless, aspirated, creaky. All these different types of sounds are possible because of the horizontal movement of the vocal folds. Thus, you have both vertical as well as horizontal movement of the vocal folds. Let's take a look at the structure of the vocal folds. There are two main muscles here that we notice, the thyroarytenoid muscle and the interarytenoid muscle, that move back and forth or sideways. The muscles are attached to the arytenoids, cartilage, that can contract and expand. The two muscles and the cartilage, as shown in this figure, are responsible for the various states of the glottis. Although the different states of the glottis are responsible for different phonation types, but let us not forget that different types of sounds produced here at the larynx are also because of the flow of air, the stronger and the weaker forces of the flow of air, and the way the muscles are held together, that is in terms of greater or less tension, is responsible for producing different types of sounds. A glottal stop. A glottal stop is the sound that is produced with the vocal folds tightly shut. It is especially found in some Austroasiatic languages of India and is commonly found in many other languages as an allophone. The important thing is that we should be sensitive to be observing when and how the glottal stop is produced in those languages. The glottal stops are a very special kind of stops. Notice that in the chart you have them placed in the voiceless slot, not voiced slot, because you can't have a glottal stop with the glottis open. So the stop is possible logically only if the glottis is closed. It is very tightly closed so that when it is suddenly open, then you hear a plosive sound, namely the glottal stop. Voiceless sounds. The voiceless sounds are produced with the vocal folds wide open, as in breathing. Now, there are only some of the sounds which are voiceless in general in languages. These are usually called obstruents. That is, plosives, affricates and fricatives. Sonorant consonants and, of course, vowels in general tend to be voiced. In the case of the obstruents, we have different symbols for voiceless obstruents and voiced obstruents. But in the case of the sonorants, because these sounds are not very frequent among sonorants and vowels, we usually use diacritics to show their voicelessness, usually a small circle. Only in some cases, such as fricatives, we may notice new symbols used for them. For example, the fricative approximant, the lateral fricative approximants, you see voiceless and voiced, they have different symbols. It is usually not very easy for beginner students in phonetics to be able to distinguish voiceless and voiced sounds. You have to learn to practice them. For example, between the two sounds s and z, s is voiced and z is voiced. How do we distinguish them? Notice that if you try and produce those sounds, you will try to feel the difference between them by putting your fingers on the larynx. You will be able to see that in one of them there is a vibration here, and in the other there is no vibration. Thus, when I produce a sound like the larynx is quiet. When I produce a sound like I can hear a vibration at the larynx. Another way to do this is to close the ears and produce the sounds like when you say z, there is greater vibration. It is the case with all the voiceless and voiced sounds. In the case of voiceless sounds, when we produce them, such as pa or ta, in comparison with ba or da, it so happens that because we produce them individually, these consonants are followed by vowels, and thus they come half of the production of voiceless consonants is almost like voiced consonants such as p, b. Now, the way to be able to learn to distinguish them is to do it slowly, Thus, when I say p, b, when I say b, there is a vibration felt on here in the vocal folds. But when I say p until a, there is no vibration felt. Try and practice this with other voiceless and voiced sounds. I'm sure you'll be able to distinguish between voiceless and voiced sounds. Voiced sounds are produced with vocal folds held loosely together with the help of the arytenoids cartilages, unlike for glottal stops, for which they are held tightly closer. As they are loosely closed, the air stream passing through them causes them to vibrate by means of the Bernoulli principle. According to this principle, as the air passes out with force through the vocal folds, the pressure drops. As the air pressure drops, the vocal cords come together again to be forced again to open. The cycle produces the effect of voicing, a buzzing sound. Aspirated sounds. Aspirated sounds are produced very much like voiceless sounds, except that the vocal cords are slightly more widely open and there is greater force of air coming out through the larynx. Now, the aspirated consonants are also slightly different from the voiceless consonants in terms of the vocal folds not closing immediately. Thus, whereas in the production of voiced consonants, the vocal folds are coming together and very close together, although not tightly shut, and they are vibrating. In the case of voiceless consonants, the vocal folds are open, wide open, so that the air passes out through them. In the case of aspirated consonants, especially voiceless aspirated consonants, the vocal folds are even more open, and whereas the voiceless consonants come quickly afterwards as the sound is released, in the case of aspirated voiceless consonants, the vocal folds don't come immediately but are sort of kept away because of the extra force of air. Now, phoneticians have found a way of measuring the distinction between voiced, voiceless, and aspirated sounds, as you see them in the diagram on the screen. For voiced sounds, you notice that VOT begins before the end of the consonantal constriction. For voiceless consonants, it's more or less simultaneous with the end of the constriction. And for aspirated consonants, voicing begins even after the end of the consonantal constriction. Creaky sounds. The glottis is not only tightly shut or loosely together or wide apart, further wide apart, but the vocal folds may be partly closed and partly open also, giving rise to different types of speech sounds, such as creaky sounds and whisper. A creaky sound is produced by holding the anterior part slightly open or loosely together and the posterior part tightly closed. Creaky sounds are symbolized with the script given here on the screen. The creaky sounds are produced with the anterior part slightly open and the posterior part of the vocal cords closed slightly. For non-linguistic purposes, creaky sounds are produced often. For example, when you are in pain, sounds such as ah are creaky sounds. In some languages, creaky sounds are also linguistic sounds. Thus, in a language, Thai, the creakiness of sounds goes with certain tones. For example, very low tones in Thai are found to have creakiness in them. So creaky, if the vowel is creaky, it is an indication of the fact that the tone is a low tone in Thai. This can happen also in other languages. We are told, for example, Bodo has a similar phenomenon. There is another type of sound called breathy sound or murmur. These terms are used for sounds which are aspirated, voiced sounds. In modern phonetics, we use the term breathy sound or breathy voiced or murmur. The difference in the production of a breathy sound or murmur and a voiceless aspirated sound is that in the production of a breathy sound or murmur, the vocal cords are held loosely apart, they are vibrating. It's just that they are slightly more wider apart than for voiced sounds, so that extra breath force comes out through them. Usually we use phonetic symbols for breathy voice or murmur as shown on the screen. The vocal folds are responsible not only for giving rise to different kinds of distinct sounds which can be distinguished for linguistic communication purposes, such as voiced, voiceless, aspirated, murmur, etc. But the vocal folds are also responsible for other aspects of voice. For example, loudness. Now, the loudness of a sound may be on account of the vocal folds may be held slightly further apart, or the muscles tightly closed, or the larynx pushed up. Any of these ways can be used in producing a loud sound. We know that the vocal cords are also responsible for producing pitches or tones in languages by changing the rate of vibration. Thus, vocal folds, vocal cords are extremely important in the production of speech, both linguistic and other aspects of speech. So the third type of speech process is called the oro-nasal process. It involves the oral tract, the nasal tract, and the portion above the pharynx. All of these three differ in shapes and sizes in different languages, giving rise to different resonances. There are three types of sounds produced by the oro-nasal process, namely oral sounds, nasal consonants, and nasal vowels. The difference amongst them is as follows. Oral sounds are produced with the velum raised to block the nasal cavity. Nasal consonants are produced with the velum lowered to block the oral cavity, and nasal vowels are produced with the velum held in a neutral position to allow air to pass through both the oral cavity and the nasal cavity. Oral sounds are like most vowels in world languages, such as A, E. Most consonants, for example, P, B, L, S, Z, all these are oral sounds. Nasal consonants are sounds such as Ma, Na, Na, Nga, etc. Now, most languages have 1 to 3, 4 nasal consonants. Malayalam is an Indian language that has at least 5 nasal consonant phonemes and more nasal consonant allophones. Nasal vowels are found to be contrastive in many languages of India, especially Indo-Aryan language. For example, Hindi, the word saas, which means mother-in-law, is contrasted with the word saans, which means breath. There are many other words which show the contrast between other nasal vowels such as E and E, U and U, A and A, etc. Nasal vowels are also found in some of the European languages as contrasting sounds such as French. English does not have nasal vowels, but English has vowels which are called nasalized vowels. We thus make a distinction between nasal vowels and nasalized vowels. What is the distinction? The distinction is that nasal vowels are contrastive units in the sound system of a language. Nasalized vowels are those which emerge as allophones in the context of surrounding nasal consonants. Thus, given a nasal consonant such as N or M, a vowel which is before or after may be nasalized. For example, when I say on compared to odd. So on, o gets nasalized because there is the following nasal. Whereas nasal vowels are not found in some languages, nasalized vowels are found in almost all languages. There is no language in which we do not find nasalized vowels. To summarize then, we have looked at two important processes of speech, namely phonation process and oro-nasal process. The oro-nasal process gives rise to rather limited types of sounds. We looked at them: oral sounds, nasal consonants, nasal vowels, and nasalized vowels. The phonation process is one which gives rise to a much larger number of sounds by making the muscles move in two main directions, namely horizontal direction and vertical direction. Also, the way the muscles are held together in terms of tenseness and the way the muscles allow the air to pass through them gives rise to several other types of sounds which may or may not be always contrastive, but which lend to the variety in the types of sounds that humans speak. Thank you.